December 23rd. I have a modified, I used some Litz wire and modified the wrap for the bifilar coil, so all the current is going in the same direction, and the crossover is down underneath here. So I'm going to try this out and see how fast it'll boil the water. I'm going to take this old melted coil off of here and put on this modified bifilar coil here on this. Okay, here we go. Start the stopwatch. Okay, notice over here the temperature was immediate on that coil. This little thermocouple right here is close to the surface of the steel knives, and we're already up to about 125 degrees and climbing. Okay, this is of course the water temperature with this thermocouple. This is the 7 knives with the bifilar wrapped Litz wire around it. Coming up on a minute. And here we are at 6 minutes. This thing is really boiling nicely. The Litz wires are a little bit warm, 100 degrees, 110 or something. They're okay, but this boiling is very nice here. We're pulling 600 watts on the mini ductor, and we're leveled out at 212 on the boiling. So I guess test successful. I'm going to add some knives to this coil. I'm going to try to put some knives on the outside and do more testing later. So there's it, off, on, off. Oh yeah, as mentioned before, finite control of your boiling process. Okay, bag's out for now. Okay, so we put some stainless steel knives around the outside of the coil to see if we could get a little bit more surface area for boiling. So the Litz wire is just a little warm, not too bad. Boiling is nice. Good test. The addition of those knives on the outside of the bifilar wound Litz wire increased the efficiency, and by about 30 seconds faster boiling. Notice how the addition of the extra knives, the temperature went more straight up than it did over here without the 4 extra knives. So it looks like adding more mass gives it more energy input, and I guess the extra 150 watts that it was using tells you about the same thing. Okay, good progress. December 18th, we got our new coil in from Hong Kong. Nice and sticky with a magnet there. Much better than this one down here, just a little bit. This one's really strong. So time to start working on the boiler coil. And there it is. We should have enough to work on here. Okay, we got the first rolled coil. Gonna put it in there, looking good. Cut some slots in it, bend it out a little bit to allow for water flow. Looking good. Yeah, we're gonna take this right out of here. This melts at about 235, and we're going to be going up to about 300 degrees and maybe 350, and these will melt at about 485, these tie wraps, so maybe they'll be good for us. Okay, we're halfway. There it is. After about a half hour of struggling with the thing one-handed, there is the bifilar wound coil for the boiler. Yeah, we got it inside the jar. Alright, very good. Okay, let's start filling this with some water. This is filtered water with a pH adjusted to 8.0. Okay, 27th of January. Don't know what to expect to have the coil in the water. Got that hammer because water wanted to run down these Litz wires, and we're going to push the button and get some readings. $166 watts. That's way down from 500 watts on our last test. I don't see anything. 173 watts. That's what this little mini ductor is pulling. And we have this thermocouple 61.9. We have some temperature rise here. It's up to 66. It's starting to increase now. 173 watts. I think we were pulling 550 before, and we're seeing if we can heat this coil up. But with this much watt input, that's not a lot. But I do see a steam bubble here. Did I just see a bubble? Okay. We'll come back. Okay, we're a couple of minutes into the test here. The watts have kind of settled out about 170-ish or so. The water temperature in here by this thermocouple here is hardly coming up at all. Here's the other thermocouple next to it. We're all the way up to a whopping 70 degrees. It's still showing 62. This coil configuration doesn't look to be very efficient to me. Okay, we can connect the wires, and we're coming over here. And how many volts do we have on that coil? Volts. $83.56. Volts is 18.4 volts, and the kilohertz or frequency is somewhere between 2,000 and 8,000. Let's look at amps. All right, let's clamp it on here and see what we got here. This is amps. 0.3 amps is coming through here. No amps. So we got 158 watts, but doesn't appear to be any current flow. Amps. Yeah, 0.2. Not good. Okay, we're coming up on about 7 minutes here. Right around 7 minutes, still 163 watts. Temperature of the water about the same as over here. 70-ish in 7 minutes. So we got to drop back and regroup here. There's no power transfer here. Bags out. Okay, so we took this one out that wasn't giving us any amps or low voltage, and we put in this little one that we tested earlier. And I'm going to push the button. Let's see, do the stopwatch and push the button. Let's see how many amps. Watts, 432. Okay, that's better. 432. Temperature 71. Okay, we got amps. 594 amps. Pretty good. Yeah, it's 5 minutes. We're up to about 150 degrees on this 1.25 gallon jug, and Guess we're seeing a few bubbles coming up here. So conclusion so far from this round of testing is this bifilar wound coil and this 2 pounds of stainless steel in there will not produce any energy. This produced some, but by far it seems the most was produced by these stainless steel knives with these on the outside of it. And that's it so far. We'll publish this, and we may need to add some capacitors to this coil here. Something's going on. Bags out.